In this video, I'm going to talk about merge sort solution to Leetcode question 912 sort an array. The problem is sort an array in ascending order. The requirement is no built-in function, time complexity in O(n) log n, and the smallest space complexity possible. The merge sort is not optimal in terms of space complexity, but it's a good starting point to the sort algorithm. So the merge sort has time complexity average equals worst equals O(n) log n, and then space complexity O(n) because it uses actual space to store the output. The main idea for merge sort is divide and conquer. It recursively splits the list in half until have lists with size 1, and then merge the split list into a sorted list. So let's start coding. So basically, we first recursively split the list in half, and then now we have the base case. Base case, that is, if the length of the numbers is less than or equal to 1. In this case, we return the array. Else, we start calling our recursive function. By calling that, we split the list in half, so we get the middle index. Basically, the index of the middle position of the list. That is the length of the numbers divided by 2, integer divide. We get the position or the index for the middle point of this array nums, and then we call the recursive function basically on the left and the right subarray. And then after that, we start merge them into a sort list. Basically, we return self.merge. And then in the next step, we are going to call this merge function. So define the merge function. So basically, the merge function is actually merge the sorted list, merge left and the right subarrays into a sorted array. So this merge function merges the left and right subarrays into a sorted array. We define two variables I and j. Basically, I indicates the current index of the elements in the left array, and then j indicates the current index of the elements in the right subarray. Basically, we compare the elements at position left I versus the position at right j, and then we append the smallest one to our output. So that's kind of how we sort them. So we define an output list. We initialize that to an empty list, and then we start our comparison. Our condition is the left subarray and the right subarray, the I and j must within the index, within the range. In that case, we compare each element. If left I is less than or equal to right j, in that case, we append the smaller one to the output. And then after that, we update the index. Since here we already compare and then considered the left I, so in the next comparison, we consider the elements at position I plus 1 in the left subarray, and then compare that with right j. Else, in this case, if right j is actually the smaller of of the two. In that case, we append the right j to the output. And then update the index. So in the end, after jumping out of this while loop, it means one of the either the left or the right subarray or both, they're out of index. So if there is any remaining elements, we just append them to the output, to the end of the output. If I is still less than the length of the left subarray, which means that we still have remaining elements in the left subarray. We append the remaining elements, actually that is extend, to the end of the output list. If j is less than or equal to the length of the right subarray, which means we still have remaining elements in the right subarray. So let's run the solution. So this solution is accepted.